So here's your screencast for a stepwise regression. I'm just going to do a backward stepwise because that's what I'm going to ask you to do on your exam. This is the data set that we used in class the other day. We're predicting the salary of an executive, there it is right there, Y, with 10 independent variables. They include things such as the age of the salary, the age of the executive, the number of years of experience, whether or not he's eligible for a bonus, the sales of the company, the profits of the company, how many people he manages, so on and so forth. So this is too many independent variables to start with. Let's screen out the ones that really do not have a significant relationship with Y. So here's our data set. We're going to say analyze. Come on, there we go. Regression, linear. Y is our dependent variable. And I can grab all of these variables and move them over. Change your method from enter to backward. And then change your stepping criteria. So there it is right there. I will give you exactly the criteria that I want you to use. Most likely I will have you change this number right here. So this is the p-value that basically is responsible for kicking out variables or letting them stay in the model. So I don't know, let's change it to 0.15. And then that's it. So this variable screening process, because that's what it is, it's just a kind of a starting point, screened out x10, then x7, then x8, then x6, and then finally x9, and then got to a point where it said, okay, everything else can stay. All right, there's your R squared summaries. So the last model, which includes x1, 2, 3, 4, and 5, as you can see right there, that bottom line, has an adjusted R squared of 916. Keeping these other variables in the model doesn't really do much for us for R squared, or adjusted. Here's the final model ANOVA table down here at the bottom. Oops, I think I went too far. And then here is the final model that I will ask you for in your exam, and you're going to write it from your coefficients table. There's your slope, there's your y-intercept, and here are your slopes. And then there's just why the variables got kicked out the way they did. So x10 came out first because that p-value was so high. And that is stepwise regression.